Okay, Bismillahirrahmanirrahim. Assalamualaikum and very good morning to my lecturer. First of all, I would like to thanks to my beloved lecturer, Segani Gapo bin Mohamed. Before we start our presentation, I would like to introduce myself and my group member. First, Alif Amiril bin Isham, metric number 01DKA21F1094. Second, Syabah Rao, anak lelaki Viswa Rao, metric number 01DKA21F1092. Thirdly, Muhammad Haikal Hakimi bin Desa, metric number 01DKA21F1093. And lastly, myself, Muhammad Azmi bin Musa, metric number 01DKA21F1091. Okay, here is some of content that we will present today. So let's start it. Okay, here is our team roles and responsibility. First, leader, Alif Amiril Adeli bin Isham. His responsibility is ensure all group member participate and divide the task to the group members equally. Communicate with the members and keep the group member aware of time constraints and deadlines. Second, our group secretary, Syabah Rao, anak lelaki Viswa Rao. His responsibility is take notes and summarizing team discussion and decision and keep all the necessary records. Ensure the group members focus on most important issue and doesn't get caught in details. Thirdly, innovator, Muhammad Haikal Hakimi bin Desa. His responsibility is tries to create harmonious and positive team atmosphere, encourage imagination and contribute new alternative perspective ideas. He also responsible to fill the missing members whenever needed. And lastly, myself as a helper, my responsibility is help with the slide. Okay, now I will continue with introduction of integration. Definition of integral. An integral is a function of which a given function is the derivative. Integration is basically used to find the areas of the two-dimensional region and for computing volume of three-dimensional objects. Therefore, finding the integrals of a function with respect to the x-axis refers to finding the area of the curve with respect to the x-axis. The integral is also called as antiderivative, as it is the reverse process of differentiation. In general, there are two types of integrals. Definite integrals are defined for integrals with limits, and indefinite integrals do not include any limits. Here, let's explore more definite and indefinite integrals. In mathematics, integrals are used to find center of mass of an area having curved sides. Second, the average value of a curve. Third, the area between two curves. And lastly, the area under a curve. That's all from me. Thank you.
Okay, Bismillahirrahmanirrahim. My name is Alif Amiril Adeli bin Isham. I'm from DKA2C and my metric number is 01DKA21F1094, and I will present about the application of integration in real life. So guys, in this last chapter of this course, we will be taking a look at a couple of application of integral. There are many others application, however, many of them require integration techniques that are typically taught in calculus 2. Therefore, we will be focusing on an application that can be done only with knowledge taught in this course. Okay, so for the first example is arc length of a curve and surface area. The arc length of a curve can be calculated using a definite integral. The arc length is a first approximate using line segment, which generate a Riemann sum. Taking a limit then give us the definite integral formula. The same process can be applied to function of y. The concept used to calculate the arc length can be generalized to find the surface area of a surface of revolutions. The integral generated by both the arc length and surface area formula are often difficult to evaluate. So example number 2 is moment and center of mass. In this section, we consider center of mass, also called centroid, under certain conditions and moments. The basic idea of the center of mass is the notion of a balancing point. Many of us have seen performers, right, who spin plates on the end of sticks. The performers try to keep several of them spinning without allowing any of them to drop. Mathematically, that sweet spot is called the center of mass of the plate. So example number 3 is areas between curves. Just as definite integral can be used to find the area under a curve, they also can be used to find the area between two curves. To find the area between two curves defined by functions, integrate the difference of the function. If the graph of the function cross, or if the region is complex, use the absolute value of the difference of the functions. In this case, it may be necessary to evaluate two or more integrals. So the last one is exponential growth and decay. One of the most prevalent applications of exponential function involve growth and decay models. Exponential growth and decay show up in a host of natural applications, from population growth and continuously compounded interest to radioactive decay and Newton's law of cooling. Exponential functions are ubiquitous in nature. In this section, we examine exponential growth and decay in the context of some of these applications. So that's all from me. Thank you.
Assalamualaikum, my name is Muhammad Haikal Hakimi Bedesa. My metric number 01DKA21F1093. Now, I'm going to explain the solution of the graph of a curve with equation y equal 1 over 3 x squared and y equal x plus 6. To determine the point of intersection A and B between two lines, you have to solve the equation first, which is 1 over 3 x squared equal x plus 6. Then multiply x plus 6 with 3 and it got x squared equal 3x plus 18. After that, change the position of 3x plus 18 to the left side. And the answer x1 equals 6 and x2 equal to negative 3. After you got the value of x, replace it in the equation, which is y equal 1 over 3 6 squared and it got 12. Same goes to the second equation, which is y equal negative 3 plus 6 and it got 3. And for the last answer is point A equal to 6 12 and point B equal to negative 3 3. Next, for the y-intercept point C, by using second equation y equal x plus 6, it got 6. And the answer is the y-intercept point C is y equal to 6. That's all from me. I pass to the next presenter. Thank you.
Okay, good morning sir. I'm Shoban Rao, son of Isfarao. Matrix number 01DK21F1092 and I'm here to explain solution C, and which is area under the curve for the region by the curve. Okay, first what I did was I found the total area, which is 1 over 2 times 9 times 15, and I got 67.5 unit. And then area 1, which is integration, and I used the equation which is 1 over 3 x square, and the integration is negative 3 to 0 for the first area, and I got the answer 3 units square. And for the second area, I used the same equation, which is 1 over 3 x square, by integration for 0 to 6, and over there I got the total value, which is 24 units square, and the area under the curve for the region by the curve is I got that by deducting 3 and 24 from 67.5, and then here you can see 67.5 minus 3 minus 24, and I got 40.5 units square. That's all from me. Thank you.
So for our summary is, we solve problem using integrations. As stated in this question, we are required to find the answer. We have to apply integration methods. We also enhance our skill on sketching graph and finding the limits of the shaded region. With integration as a mathematical techniques, we have been able to read the solution of the different method used. The method brings a simple and clear way, thus can be used for practical data. We can say that mathematics are very important in our daily life. So we have to learn them as much as possible to understand it. The student also have learned how to apply the formula to solve the given question. So that's all from us. Thank you.